YouTube Music Premium. Set a trial.
Hello everyone, good morning, see you again. We are on the video chapter 3. This is the continue from the live class last week. So we are at the chapter 3. Okay, let me share with you the PowerPoint. Okay. Right, I think let me go through. Okay, I stop somewhere here. Then I would like to explain a little bit on here image histogram. So let me look at this. Right. Okay. So this is the image histogram. What is the histogram? Histogram. What is histogram? Histogram of an image shows us the distribution of gray level in the image. One image, if you have one image is actually represented in row and column, right? Row. So row and column got pixel. Yeah. Got pixel value dot here, right? Pixel value 0, 2, 2, 5, 5. So if you have, for example, 1 megapixel, 2 megapixel size of image, 10 megapixel. So you have a lot of pixel here, and each pixel contain this value 0 to 5. So in order to analyze image, we want to see the distribution of gray level in the image. So we use image histogram. For example, this one, right? 0 until 5. Then you can see the distribution. Okay, at this range, This is very important to do the analysis. For example, this image. So this is the distribution. 0 to 5. You see here, looks dark, and then you can expect how distribution looks like. Okay, at the low level. Bright, and then you can see at the upper level. Okay, got black, also blur, and then at the middle. Sharp means that distribution is good across the pixel value 0 to 5. Okay, so this is the histogram of each image, and then we can do analysis. We can get some knowledge of the pixel distribution of the image. Okay, for example, if we get this, then we want to get sharp image like this, then we can perform histogram equalization. So this is the formula. Histogram equalization like this, then stretch to become. So this pixel value can be equalized so that we can get a good image. Okay, this one equalized. So this is the example. I mean the detailed calculation, but if you were to do this equalization, you don't have to do manual. You can just use software. But to get the knowledge of equalization, then you can do it manually. So this is the example you can do by yourself. So equalization got a lot of what do you call it, transfer function. You can use this transfer function. It depends to method or technique for the equalization. Then you will get the output of the image. So for example, this one, maybe you use a certain type of equalization technique. So this is another example I see of equalization. So you can do this exercise. Okay, done the histogram. Next is a partial filtering. As I told you last class, partial means that we are doing direct manipulation of image. So this is, for example, pixel. You got 2.5, for example, here. Partial filtering means that we are perform pixel to pixel. So this is the partial filtering technique: neighborhood operation, partial filtering, smoothing operation, what happened at the edge, correlation and convolution. So we go to the filter. This is actually the basic art of linear filtering. Very straightforward filtering. Okay, this is the mathematical equation. Okay, so this is how the filtering perform. The mechanic of partial filtering, the magnified drawing shows a 3x3 mask and the image section directly under shown displays out from under the mask for ease readability. So you have what mask? If you want to perform a filtering, then you need to have mask. So W00, W01. So this is all value of mask of your filter. That when you perform to an image, this is the pixel of image section under the mask. So how it works? So this is the formula. Okay, again, this is the example. This is your mask, your filter. Filter. Right, then you just perform the mask on top of the pixel of image. So this is the formula, how to calculate the pixel value after you perform the mask. Okay, then you get the new filter output. This is the video. This is another example of mask. You got this original image. This is the image A, B, C, D, E, original image pixel. Then you perform filter on this image 3x3, which is the filter value is RS, T, U, V, W, X, Y, Z. Then to get this point, at this point, this is the formula. So this process is repeated for every pixel in the original image to generate the smooth image or output of the filter. So you can try this example, right? So this is the filter type, simple partial filter option, smoothing operation, 1/9, smoothing operation. Okay. This is the example, simple 3x3 neighborhood, perform the 1/9. Okay, then you will get, at this point, you will get 98.33, then you just move to another point, this point until the end. Then you will get the smooth output of filter. So this is the example of smoothing, filter smoothing. Okay, this is another weighted. See, you have original image where you can't see it's difficult to count the object, then we perform smooth, then perform again threshold the image to get the good output. So this is the same example of the filter. Okay, strange things happen at the edge. So this is the at the edge when you perform any process at the edge. This is the something happen at the edge. There are a few approach dealing with the missing edge pixel. So this is the missing edge pixel. So the last one is correlation and convolution. This is another filter: low pass, high pass, band pass, band reject. Okay, linear, nonlinear spatial filtering, correlation. So I don't want to go to the detail of this one, but you can just see. Okay, so this is all the example of filter. Okay, so that's all for the chapter 3 part 1. We still have a chapter 3 part 2. Thank you. See you again. Bye bye.